Limits.
Derivatives.
Integrals. Series.
Long ago, the realms of math lived together in harmony. Then everything changed when BC calculus attacked. Only the Avatar, the master of all calculus, could solve them. But when the world needed him the most, he vanished. 100 Fs passed, and my brother and I discovered the new Avatar, a scholar named Patrick. And although his algebra is great, he still has a lot to learn before he's ready to teach anyone. But I believe Patrick can save the world.
Peter! Oh my god, your score on that last calc test, you're such a failure!
You didn't even take the calc test!
Oh my, how could you not know how to do integration by parts?
You're a slut. This is why Dad left me in charge of the village when he left us. Go make me a sandwich!
You filthy, misogynistic piece of work! This is why Mom left me to
Wait,
do all the
stop,
work.
stop, stop. Look.
Look, there's a boy in here.
What were you doing in there?
Studying. Wait. Calculus.
That night, Patrick was alone, studying for an upcoming calculus exam. He heard a knock at the door and thought he heard the integral master, so he hid in the closet to study. Little did he know that it was just Mr. Harrelson. He locked himself in and was stuck in a state of thinking for almost 3 days.
Well, do you remember any calculus?
I only know series.
Well, to pass this test, you must know limits, integrals, and derivatives.
I'm a master of limits. Meet me at 3 p.m. sharp at Miss Satya's room.
As the Avatar, Patrick needed to start from the beginning, limits.
Ready to learn about limits.
Okay, let's get started.
The limit of a function is when variable x approaches a finite value at point C. Typically, limits can be solved by plugging in the value that x approaches and solving from there. In a special case, when x approaches infinity, there are 3 special rules you need to know. If the exponent is larger in the denominator, the value approaches 0. If the exponent is larger in the numerator, the value does not exist, or alternatively approaches infinity. If the exponents are equal in the numerator and denominators, simply divide the coefficients.
Let me try.
After learning limits, he traveled to another part of the school to learn derivatives. This would be the most challenging topic Patrick had to face yet.
I'm excited you are here to learn about derivatives. Are you ready?
Yes. Yes, I am.
Alright, let's get started.
The definition of a derivative is the limit of f of x plus h minus f of x quantity divided by h as h approaches infinity. The derivative is also known as the instantaneous rate of change and can be calculated by subtracting one integer from the exponent and multiplying to the coefficient of the function. This is called using the power rule.
Let me try.
Patrick then traveled to a land unknown to the rest of the world so he could learn another important topic, the antiderivative.
What do you want?
I'm preparing for a big calculus test. I've learned all the aspects of calculus except for integrals. Will you help me?
What makes you think I would help you?
I need to pass this test. The world needs the Avatar.
No, you're not gonna pass this test. Hundreds of the world's geniuses have tried but failed horribly.
Please?
Fine. The antiderivative, or the integral, is defined as the area under the curve, or the total accumulation of rates of change. The general form of the antiderivative is an integral bounded by b to a of the function f of x dx. The antiderivative can be calculated by adding the integer to the exponent and dividing the function by the new exponent value.
Let me try.
Days passed, and the day of the test was at hand.
Patrick, are you ready? Are you ready to face the teacher?
I need more time.
You need to calm down. Series are simply a way to tell whether graphs diverge or converge. You know this.
Oh, I think I remember. A series is a total summation of values from n to infinity. Series are usually determined to converge or diverge at a particular value. The most important convergence tests you need to know are the following: the ratio test, the p-series, and the geometric series. The ratio test states that the limit of a sub n plus 1 over a at sub n is equal to L. If L is greater than 1, the series diverges, while if L is less than 1, the series converges. If L is equal to 1, the test is inclusive. The p-series states that the series 1 over n to the p converges if p is a value greater than 1. The geometric series states that a series converges at the value equal to a over 1 minus r, only if r is greater than 0 and less than 1.